Hello everyone and welcome to Van Tech Corner. In this video, we're going to build a 10 gig routines OpenWRT test lab with the Emulex OCe14102 dual XFP plus Ethernet adapter. So right here we have two XFP plus port and it is 10 gig. And then for the PCIe connector, it is PCXA. Alright, so this is the brand, and then you will have PVID or something like this, and at the back we have the PCI address as well as the product number right here. Alright, so this is the Ethernet adapters, and from some of the information, this device is working really well with OpenWRT. So I'm going to test this out with the Zimaboard, which also have a PCIe X4 connector, and then I will be setting up the connection with the QSFPTEK XFP module. So it is a XFP plus module anyway. Alright, so I also have the Zyxel switch. It is also a 10 gig switch as well. So right here we have this XFP plus port, and those 1, 2, and 3 also a multi-gigabit Ethernet. So this port support 1, 2.5, 5, and 10 gig in RJ45 connection. And this is the XG125012 from Zyxel. Now let's talk a little bit about how to connect the XFP Plus adapter to the switch or to your PC. Well, you will need some orders adapter. For example, right here I already done the test with the Mellanox ConnectX-3, and you can see that this is also an XFP Plus port, and in order to connect those ports together we will need either a DAC cable such as this one. So this is a DAC cable from Mellanox, and this is made of copper inside, and beside the DAC you can also use fiber cable. So right here I have a fiber cable from QSFPTEK as well, and this is a LC to LC UPC duplex OM cable. Alright, so let me show you how it works and how we can connect it together. So this is the cable, and usually the cable can be in a single mode or multi-mode, and you need to check what is the compatible cable for your module. For example, for this module, let me take it out. So this is the QT XFP Plus SR. It is a 10 gig, and we can see that the connectors is also LC. Alright, so we will need the same cable in order to connect them together. So usually this is how we connect it together. So you need to remove the covers. Alright, 1 and 2, and then we can just slightly and put them in, and that's it. The fiber cable is connected right into this XFP Plus module. After that, it will be connected to maybe to the switch like this. Alright, very good. This is how we can connect them together. And we will also do the same on the other end. Alright, let's remove the cover as well. Now, alright, you need to plug it in until you hear the click sound. So after that, it will be connected like this. Alright, so in order to remove this XFP Plus adapter from this one, you need to first remove the cable. So press and hold and pull it down, and after that you see that we have this ring, or I don't know how to call it. We just need to pull it down and pull it out. Alright, so this is how we connect them or unplug them. Alright, Now let's install these modules on the Zimaboard, and after that we're going to build OpenWRT with the driver or the kernel module for this one in order to work. So this is a 3D print holder for the Zimaboard, and it won't fit this high profile bracket anyway. So I will need to take out the XFP Plus module, and then remove the high profile bracket. Lastly, let's put it in very well. So we can see that the module fit right in. However, we have a little space because one of the components is too high. Now let's go back to the computer to install OpenWRTs on this USB drive, and after that we will be back to the Zimaboard to boot up OpenWRT. In order for the Emulex OneConnect adapter to be up and running, we will need the KMod B2 net. And you can install OpenWRT, after that install this package, or you can build OpenWRT with this package pre-installed. So I'm going to do the second way, which is download the OpenWRT with this package. So let's go to OpenWRT, firmware-selector, and then we're going to search for x86-64 right here. And after that, I'm going to go with 22.03.3. So this is a stable build, not a nightly or snapshot anyway. So let's go and click on the customize install package. And right here, I'm going to add this KMod B2 net. And I'm going to add HTOP as well to monitor the CPU users, as well as the BMON to see the bandwidth. Alright, let's click on the request build and let's wait for it. The build was successful. Let's download the firmware, and for this test I'm going to go with the combine ext4. Alright, so now we can go and open root first application, and after that select the firmware that we have just downloaded and hit start to write it on the USB drive. Alright, it is ready. We can now remove the USB drive from the computer. We're back to the Zimaboard, and right now you can see that the USB drive with OpenWRT has been installed. And right here I have the USB receiver for the keyboard, because later on I will need to configure something with the device. So right here I have a small HDMI monitor. It is connected to the Zimaboard, and for the power, it is using a separate power cable. So it won't take the power from the Zimaboard. And then in order to measure the power consumption, I'm also using a power meter right here so that we can see what is the power loss of this module. Very good. So we already have the power, and now let's put everything nicely and let's try to power on the device. Alright. So right after power on, we have 9.2 and now it's go to 10. Alright. So I'm going to press the delete key to go to the BIOS. I'm not sure if you can see it, and now I need to change the boot order. Let me see. So the first boot should be the USB drive anyway. Now let's save and apply. Yes. We can see that OpenWRT is being loaded. So right here, I already see some update about the B2 net, and I assume that this Ethernet adapter should be up and running right now. So this Zimaboard have two internal gigabit network port, like this one and this one. But when we add another Ethernet adapter like this Emulex OneConnect, usually those interface will become Ethernet 0 and Ethernet 1. So now let's do a blink try. So this is the DAC cable from my computer. And now I'm going to do a blink try by connect it to one of the XFP Plus port and hoping that OpenWRT will assign this port as LAN port instead of the RJ45 port. So let's give a try. And very good, we can see that the BR-LAN link already become ready, which means this port is now Ethernet 0 and it is automatically configured at the LAN port. So with that being said, I assume that this port should be now Ethernet 1 or the 1 port. So now I'm going to take the fiber cable from the upstream switch, from the Zyxel switch that we have previously, and let's connect to the Ethernet 1 port. Very good. And we have an update right here that Ethernet 1 link become ready. So right now we should have a working Ethernet connection with this one at a LAN port and this one at a 1 port. So the power consumption right now is 11.3 watt for 2 XFP Plus ports activated. Let's go back to the computer and check it out. Alright, so we see an active network show up right here. I will press yes. And now let me disconnect the Wi-Fi connection. And let's go to the network and internet setting and check the adapter option. So right here we have the Mellanox ConnectX-3 up and running with the link speed of 10 gigabit. And let's log into 192.168.1.1. So unfortunately, LuCI is not pre-installed. I'm not sure what is wrong, but when we build a firmware from here, even though we did a stable build, we will need to add LuCI package or else it won't be included. But anyway, let me connect to the Zimaboard or the OpenWRT router with added edge and we can install the package manually. Alright, so sudo opkgs update opkgs install LuCI. We're very lucky that OpenWRT picked up the Emulex OneConnect at Ethernet 0 and Ethernet 1 so that we can have the connection to the device, or else we will need to connect to it via the RJ45 and do some further configuration. So now let me open a private Windows and go to 192.168.1.1 and let's log in. So here is OpenWRT 22.03 up and running on the Zimaboard with the N3450 CPU. Very good, let's go to network and interfaces and have a look. So on the device tab we have Ethernet 0 and Ethernet 1. Those are the MAC address of the Emulex OneConnect, and these are the MAC address of the Rotex internal gigabit adapter. Alright, so we have a working one connection, and right now I believe we can do some speed tests. So right now on the global network option, I have just enabled the packet steering, and I have an iPub3 server as well an OpenSpeedTest server on the one side. So right now our LAN IP is 192.168.1.1 and the one IP of the Zimaboard is 172.16.9.72. On the one side, I have an OpenSpeedTest server at 172.16.9.71, and now let's have a quick speed test. So let's go and see what do we have. Very good, we are having 5200 Mbps download, and let's see what is the result for upload. So for upload, we have a slower speed, it is at 2200 and the page will crash. Alright, unfortunately, this is not expected at all. Let's restore the page. So let's run the test another time. I hope it won't crash again. But we can see that the upload speed is really slow. It is just half the download speed. So now I will need to enable the shortwave offloading, and it looks like that the Zimaboard is not powerful enough to handle the 10 gigabit throughput, because anyway the OneConnect module is PCIe X8 and the Zimaboard is only PCIe X4. Alright, let's refresh the page and run the test for another time. This time we have more or less the same speed, which is 4679 Mbps for download and just 2200 Mbps for upload. So perhaps this is some limitation from the Emulex adapters or from the Zimaboard, but we have seen that so the speed is not what I expected. So let's give another try with iPub3 before we go to the power consumption check. Now let's go with iPub3-C, and then it will be 172.16.9, and let me check the IP address. Alright, so it is 172.16.9.71. Alright, .9.71, and then T, I will put it 20. T 20s, and then for the third test, we're going to go with P4. So we can see that the speed is not stable. So we have 4.55 and then 5.76 and 4.30. So the throughput with iPub3 is not stable at all. So how about a revert test? Let's check it out. So for a revert test, we have a higher result. It is 6.15 gigabit per second. This is more or less acceptable, but I'm using a multi-stream, so that could be the problem. Let's run the test with just a single stream and check it out. It is weird that with a single stream I only have 1.66 gigabit per second, but if I run the test with 4 streams, I have 6.22 gigabit per second. So this is something I'm not really understand, so perhaps if you know what are the reasons, you can explain in the comment, and I really want to learn about it. So we know that if we run by 4 stream, we have 6.33. So what if I run with a stream? So we are having the same throughput at 6.44 gigabit per second. So perhaps the more stream we have, the more throughput we have. So this is something not right. I'm not sure if you have the same thinking with me. So usually the more stream we added to the iPub3 test, the lower throughput we have, but this time it is different. So what if I run the test in revert mode? So we can see that even though I run the test in revert mode, I'm still getting 6.15 or 5.6 gigabit per second, and it is not stable. But anyway, this is the result we got, and we cannot do anything to change it. So let's take a final look before we proceed with the power consumption test. So right here, I will make sure that the shortwave offloading is enabled, and then on the network interfaces, I will make sure that the bridge line is correct and I have the packet steering enabled. So now let's go back to the Zimaboard and take a look at the power consumption. Alright, so we're back to the Zimaboard, and right here I have two XFP Plus ports up and running. This one is connected to an XFP Plus module from QSFPTEK, and then it is connected to a fiber cable to my upstream routers or the switch. And this port is connected to a DAC cable, so it is a copper cable. And right now we have the power consumption at 12 watt. So right now there is no throughput at all, so everything is in idle state. So let's kick off the iPub3 test and let's check it out. So right now we are running the iPub3 test at 6.40 gigabit per second with a stream, and the CPU is at 41% idle. So we can see that the loss is on several cores of the CPU, and the power consumption had increased to 14.8 watt. So right now the module is very hot, and if you put your hand on it, you can feel the heat from the heatsink. Alright, so from 11.2 to 14.8, so it is not much for 6 Gbps-12 LAN throughput. Alright, so the test is done, and now the power consumption go back to 12.3. So just now we see it is around 15, so it is just around 3 watts of power consumption for 6.4 gigabit throughput. So to me, this is a really good result to see. So let's run the test again, but this time it will be in revert mode. So right now we are having around 6.16 gigabit per second throughput with iPub3, and the power consumption is around 14.8 or 15, and we can see that everything is working really well. There is no problem, no crash, no kernel panic at all. But the throughput from 1 to LAN is a little bit slow compared to what I expected. Alright, so I think we're done with the routing, which is the 1 to LAN throughput. And now I'm going to put this port as well, this port to the LAN switch, and we're going to have a bridging test. Alright, so let's do it together. Alright, so let's go to network interfaces, and right now let's go to the devices tab. I'm going to change the one port to maybe something like Ethernet 3 for example, because this is not being used, as well as this one. And now I'm going to go back to the devices tab, go to the LAN bridge, and I'm going to add the Ethernet 1 to my WAN port as well. So now Ethernet 0 and Ethernet 1 are in bridge LAN, so they are all in the same bridge. Hit save and then save and apply. And the next thing I'm going to do is go to the LAN bridge right here, and then I'm going to turn off GSCP server. I'm going to do the same for the IPv6 as well. So let me see, right. So GSCP, going to disable this one, hit save and then save and apply. So after this, we can go and disable the network adapter, and after that, turn it on again. Now we are having an IPv4 address of 172.16.9.73, and the test server is on 172.16.9.721. Let me refresh the page and let's proceed with the speed test. We can see that the result is more or less the same with what we have. It is 4600 Mbps for download and 2300 Mbps for upload. How about iPub3? Let me give a try. Alright, so let's run the test again and let's see. So we are reaching 6.43 gigabit per second. So I did a bridging test from the port Ethernet 0 to port Ethernet 1, and we can see that it looks like the result is very stable for now. Let me go back and reduce the stream to a single stream and let's see. So running the iPub3 test in a single stream, I only have 1.42, 1.66, 1.92 gigabit per second. So we can see that the result is very similar to the previous one that we did with a 1-to LAN or a router test. We can see that the bridging throughput that we got is very similar to the routing throughput. So I don't think I need to run the power consumption test again, but we already have the result. So far we have done the test with the Emulex OneConnect XFP Plus adapters, and we have testing the QSFPTEK XFP Plus adapter with the fiber cable as well as the DAC cable to my computer. And the throughput is stuck at around 6.4 gigabit per second with shortwave offloading enabled, and perhaps there's something I can do to improve it. It can either be the PCIe throughput of the Zimaboard is only X4, while this module is PCIe X8. That's why we only reach half of the speed. Or it can be due to a mixture of fiber cable and then DAC cable. So anyway, I'm going to test from my side and see how I can improve it. And if there's an update, I will let you know. So that will be all for this video. Thanks for watching and see you in the next one.